Hi everyone, today we are going to be starting our chapter on area and volume. This is chapter 11, and today's lesson is really going to be a review lesson. Most of the topics that we cover today are things that you probably learned at some point in middle school. We're just going to go over some basic area formulas, and we're going to talk about how to find area of two-dimensional shapes. So again, this will mostly be a review lesson. I'm not going to spend too much time talking about each formula and each shape because I'm sure that you've done this before. We've actually done some of these shapes already in this year in geometry. We've talked about area of triangles and rectangles and whatnot. So just to review, what does area actually mean? So when we're talking about a two-dimensional shape, something like a rectangle, for example, if you're finding the area of this rectangle, we're trying to find the amount of space it takes up on the inside. So for example, if the length of this side here was 5, let's just say 5 inches, and let's say the length of this side was 10 inches, what they probably showed you in middle school was that each of these inches here represents like a square, right? So we have 1, 2, 3, 4, 5, so 5 inches here, and then across the side here we would have 10 boxes here, and if we counted up all the boxes, we would have 50 boxes altogether. So a short way to find the area of a rectangle is just multiplying these two sides, right? Because we would have 5 rows of 10 boxes. And when we measure area, we always use square units because that's how area works, right? It represents how many little squares are inside of a shape. So the area of this rectangle would be 50 square inches. And you can write that like this, inches squared, or you can write out square inches. Okay, so that's kind of the basic definition of area. It's just the amount of space that a two-dimensional object takes up. So I'll go ahead and write that over here in this definition. So the area of an object means the amount of two-dimensional space an object has. And units of area are always square units. So like inches, squares, etc. Okay, now we're going to go over some of the basic formulas for area. And again, most of these you've done before, either in middle school or some of them we've talked about this year. So this is just going to be a quick little review. So the area of a rectangle is just length times width. Sometimes we use base and height to designate the length and the width. Same thing. You just take the two sides and you multiply them together. A parallelogram is basically like a rectangle. So if you think of a parallelogram as kind of like a rectangle that's just been tilted over, right, it would still take up the same amount of space. So the formula for a parallelogram is actually the same. It's still just base times height or length times width. The height, however, is always going to be measured vertically. So you can measure it on the inside of the parallelogram right here so that it's perpendicular to the base, or you can measure it on the outside of the parallelogram over here. Same thing, perpendicular to the base. The area of a square, a square is basically a rectangle, so it's still length times width. However, with a square, the sides are equal. So a lot of times you'll see the formula looking like this, side squared. That's because side times side would be side squared. But it's still the same. It's just length times width or base times height. A triangle, as we know, we've done triangles this year. It's 1/2 base times height. Or some people do it like this, base times height divided by 2. And then a trapezoid, it's probably been a while since you found the area of a trapezoid. Trapezoids have 2 bases. So we do 1/2 of the height times base 1 plus base 2. It's kind of like the formula for a triangle. Triangle is 1/2 base times height. This is really like 1/2 base times height. You just have 2 bases. So we're doing half of the bases added together times the height of the trapezoid. And then one thing to note here, especially with triangles, is you just be careful when you're identifying what the height actually is. So remember, height has to be perpendicular to a base. So it's got to make a right angle. It's got to be completely vertical when we're talking about a base. And with different triangles, the height might look different. So sometimes the height is going to be on the inside of the triangle. So in this example, the height would be right here, right down the middle. In a right triangle, let's assume for a second that this one is a right triangle, the height would actually be part of the triangle. It would just be this side right here. Here's another example where the height would be, you know, right down the middle as part of the triangle, perpendicular to that base on the bottom. And then here's an example where the base is not actually on the bottom. In this triangle, I would probably use this top side as the base, and I would draw my height in like this. Now you can really use any side as the base as long as you make a height that is perpendicular to it. And then sometimes the height really should be drawn outside of the triangle. So for example, in this picture, this green part right here, that's the actual triangle. And then the height, we could draw it outside of the triangle. So just imagine that it's going vertically down like this so that it's perpendicular to that bottom side. Okay, so go ahead and turn the page. We'll do a few examples. Okay, so in this section here, we're going to find the area of all of these two-dimensional shapes. So we're just going to use those formulas from the front page and just quickly find the area of these. So you could probably do most of this on your own, right? Just make sure you're checking back periodically to see if you're getting the right answers. So number one, this is a square, right? We have these two sides that are equal. So the area of a square is just the two sides multiplied together. So we could do 8.5 times 8.5, or you could think of that as 8.5 squared. And if you multiply that out, you would get 72.25. And always make sure you're putting units on your answer. That would be square feet. So 72.25 square feet. Number two is a triangle. So triangles are 1/2 base times height. So in this example, the base is 15 and the height is 21.3. So you can just do 1/2 of 15 times 21.3. Or you can, for easy calculations, you can multiply these two sides together and then you can just divide by 2. That's the same thing as doing 1/2. So that would equal 159.75 square meters. All right, number 3, this is a parallelogram. And parallelograms are kind of like rectangles when we're talking about area. It's just base times height. So the base of this parallelogram is the 12.9, and then the height is this right here because that's perpendicular, so that's our height. So we'll just do 12.9 times 7.1. So we have 91.59 square inches. Okay, this next shape is a trapezoid. It's got this one set of parallel sides here. We know it's parallel because these two angles are 90 degrees, and if you have angles that are in between two lines like this, as long as they add up to 180, that means that these have to be parallel. That's called the consecutive angles theorem. We learned that a long time ago. But this is a trapezoid. You can kind of tell by looking at it. It looks like a trapezoid. And the formula for a trapezoid is 1/2 of the height times base 1 plus base 2. So the height of a trapezoid, that's always going to be perpendicular to the bases. So in this trapezoid, the bases are 7 and 13. The bases are always the parallel sides, which means the height would be this 5 right here. That's the height. We could call this one base 1, this one base 2, which means we're not actually using that 9 at all. You're not going to use that at all to find the area. So let's do it. We would have 1/2 of the height, which is 5, times the bases added together, 7 plus 13. Now, if you want to use a calculator, you could just type all that into your calculator, but this is pretty easy to do without a calculator. You can add the 7 and the 13, that's 20. So this would be 1/2 of 5 times 20, which is half of 100, which would be 50. So it would be 50 square millimeters. All right, so in number 5, we have another trapezoid here. So we've got these parallel sides. And again, we have a lot of extra numbers here that we're not going to end up using. So with trapezoids, remember you need the bases. So that's these purple sides here. And then you need the height, which would be this 16. So we are not going to use the 21. We're not going to use the 16.5. So it would be 1/2 of 16 times 19 plus 27. And again, you could calculate that out. You could put it in your calculator. I'm going to let you go ahead and do that part. If you calculate all of that out, you should be getting 368 square centimeters. This next one is just a rectangle, so it's just base times height. So 3.7 times 10.5. That should be 3885. All right, and then in number 7, we have a triangle. So triangles are 1/2 base times height. Just make sure you're using the correct sides here. So in this example, the height, see how we have this right angle here? That's going to be your height. So heights are always perpendicular. And it's perpendicular to the base, which is this bottom side here. So we're going to be using the 29.5 as our base, which means we do not need this other side. So we're just going to do 1/2 of 29.5 times 14. And if you multiply all of that out, you're going to get 206.5. All right, and then finally number 8, this is a parallelogram. And remember, parallelograms are just base times height. Just make sure you're using the right sides here. The base is going to be this 11.8, so that's our base. And then the height, remember, it has to be perpendicular, so that would be this vertical side here, the 16.1. So we're not using that 18.5. So it would just be 11.8 times 16.1. And if you multiply that out, you should be getting 189.98. Okay, so now we're going to look at some examples where we don't have all the information that we will need. So these 6 or 8 problems here, these were kind of simple because we had everything we needed. We had the base, we had the height. All we had to do is plug the numbers into the formulas. And in these examples, we're going to be missing some information. So we might have to either find the base or find the height before we can actually find the area. So let's take a look at number 9. This is a triangle, and we know that triangles are 1/2 base times height, right? So if we're looking at this triangle, we have the base is 7, but this side over here, this 18.2, that is not the height. The height has to be perpendicular to the base, so the height would be this purple side right here, and we don't know what it is, so we're going to have to figure it out before we can find the area. Now we do know this is a right triangle, and in right triangles, remember, we can always use Pythagorean theorem to figure out a missing side. So that's a squared plus b squared equals c squared. It's something we've done many, many times in this class. So let's go ahead and find it. Now in this triangle, c would be the 18.2. That's our hypotenuse. So we could say 7 squared plus the height squared is going to equal 18.2 squared. And then you can just go ahead and solve this out just like we used to do. I'm not going to go through the steps of doing that because at this point we've done Pythagorean theorem many times. So h squared would be 18.2 squared minus 7 squared. And then eventually you're going to square root that to get your answer. And if you do Pythagorean theorem correctly here, your height should be 16.8, which means now we can go ahead and find the area. So the area of this triangle is 1/2 of the base, which is 7, times the height, which we just found to be 16.8, and you can just multiply that out to get your area. So it should be 58.8 feet squared. Okay, let's look at number 10. So in number 10, we have a triangle. This looks like an equilateral triangle. I can tell it's equilateral because all the sides are equal. They're all 14. Now we have the base. The base is this bottom side here. That's 14. And once again, we do not have the height. If I were to draw in a height, it would start from the top of this triangle and it would just go straight down like this so that it's perpendicular to that base. So this would be our height right here. So same thing, this is going to involve Pythagorean theorem. So if you're looking at how to set this up, it's going to be slightly different than the last one because we're only using half of this triangle when we do our Pythagorean theorem, because this would be the right triangle right here. So when we set it up, the hypotenuse is going to be the 14, but the legs are going to be, we have our h, right? And then we have this piece right here, which is not 14. It's going to be half of 14, which is 7. Because that's what happens when you split an equilateral triangle down the middle like this. You would have equal pieces down here, so this would be 7. So now we can do Pythagorean theorem. 7 squared plus h squared equals 14 squared. And then same thing here, we're going to solve for h. So h squared would equal the square root of 14 squared minus 7 squared. And you can just type that in your calculators. The answer here would be about 12.12. That's approximately the height. And then now we can just go ahead and plug it into the area formula. So it's 1/2 of the base times the height. The base of this triangle is 14. The height is 12.12. And then if you just multiply all of that out, you're going to get about 84.8. Okay, so we've done 2 examples so far where we've had to use Pythagorean theorem to get the height of these triangles. Let's look at this last one over here. This is a trapezoid this time, so we're not working with a triangle, we're working with a trapezoid. And with trapezoids, the formula for an area of a trapezoid is 1/2 of the height times the sum of the bases. Now we have the bases, right? So the bases are the parallel sides. So it would be 19 and 7. So we could call this one base 1, this one base 2. What we're missing here is the height. And this one's a little bit more complicated. So if I were to draw a height here, it has to be perpendicular to one of the bases. So this would be a good example of the height. Okay, now you could draw it on that side. You could draw it on this side if you like. Either one is fine. Now we could do Pythagorean theorem if we knew the length of this little piece right here. Because we have this, right? That's the hypotenuse. We would just need the length of this piece. Now, because this trapezoid is isosceles, so remember, isosceles trapezoids, they have 2 equal legs. So see how this is 10 and this is 10? That's isosceles. That means if I were to draw another height over here, this piece would have to be congruent to this piece. And another thing that we know is that this bottom side is 7. If that's 7, then that means the distance from here to here is also 7. And if the whole thing is 19, we could just subtract these to see what we have left. So 19 minus 7, that is 12, which means 12 centimeters has to be split between this piece and this piece. So each of these would have to be 6. And now we have everything we need to figure out this height, because now we have this right triangle over here and we have 2 sides of that right triangle. So let's go ahead and do Pythagorean theorem. So it would be h squared plus 6 squared equals 10 squared. And then we can go ahead and solve this out. So h squared would be, h would equal the square root of 10 squared minus 6 squared, which is 8. And once we have the height, now we can use this trapezoid formula up here, and we can find the area of this trapezoid. So it's going to be 1/2 of the height, which is 8, times the sum of the bases, which would be 19 plus 7. And then you can go ahead and calculate that out in your calculators, or you can just do mental math here. If you calculate that out, it should be 104 centimeters squared. Okay, go ahead and turn the page. We're going to do a couple more examples doing some different things with area. Okay, so on this page we have some word problems, and we are going to be using the area formulas to go backwards and find some missing measurements. So in most of these examples, we're going to be given the area of the shape, and we're going to have to use the information that we have to just find another missing piece. So let's go ahead and read this first one here. It says a triangle with an area of 45.5 square centimeters has a base that measures 14 centimeters, and they're asking us to find the height. So we know that the formula for area of a triangle is 1/2 base times height. So we're just going to take the information that we have and plug it into this formula. So we already know the area. The area is 45.5. So that's going to go right here for area. So we could say 45.5 equals 1/2. We also have the base, right? The base measures 14. So for the base, I'm going to plug in 14. And the side that we don't have is the height. So I'm just going to call that h. That's the missing side. And then now what we have is just a regular equation, right? We can just use our algebra skills to solve for h. So it's a pretty basic equation to solve. What I would do is just do 1/2 of 14 first. 1/2 of 14 is 7. So we have 7h equals 45.5. And then you can just divide both sides by 7. So the height here would be 45.5 divided by 7, which is 6.5. So we'll say that the height is 6.5 centimeters. So that's kind of how I would approach these types of problems. I would take the formula for the shape, plug in the information that you have, and then just solve the equation for the missing side. Okay, so number 13, this one is a parallelogram this time. So remember, parallelograms are just base times height. And the area is 160.5. The height is 7.5. So we could say 160.5 equals the base times the height, which is 7.5. So this is a really quick one to solve. You can just divide both sides by 7.5. So the base would have to equal 21.4 inches. One important thing to note with these types of problems, make sure you're not doing square units for these, right? I'm just doing regular centimeters, regular inches. We're not doing square units because we're not finding an area. We're just finding the length of a side. So that should just be normal units. Okay, number 14, this is a trapezoid. So I'm going to go ahead and write down the formula for a trapezoid just so we have it here. So trapezoid is 1/2 of the height times the sum of the bases. Okay, so let's read what we have. We have the one of the bases, right? So it says base measures are 23 and 29. So we actually have both of the bases. So base 1, we could call it 23. Base 2, we could call it 29. With the bases, it doesn't matter which one's which. And then they give us the area, which is 390. So we're going to go ahead and plug all this into the formula. So we'll say that the area is 390. That's going to be equal to 1/2 of the height times the bases added together. So 23 plus 29. Okay, now solving the trapezoid formula can be a little tricky. Here's how I recommend solving it. I would add your bases together first to just simplify that a little bit. So 23 plus 29, that is 52. So I'm going to rewrite this. We have 390 equals 1/2 of the height times 52. Now you have a couple choices here. Some people would choose to get rid of the 1/2. What I would do is just do 1/2 of 52. I know there's an h in the middle, but that doesn't matter. You can multiply in whatever order you want. So we'll do 1/2 of 52, which is 26. So 390 would equal 26 times h, and then you can just divide both sides by 26. So the height would be 15. So we'll say the height of this trapezoid is 15 kilometers. All right, number 15. So this time they are asking for a perimeter. So it wants the perimeter of a square that has an area of 361. So remember, squares have equal sides. So these are going to be equal. And if the area of this square is 361, that means that if you took the two sides and you multiplied them together, it would equal 361. So that would be like s squared equals 361. So to figure out what each side was, you could just do the opposite of squaring, which is square rooting. So the square root of 361 is 19. So that means that one of the sides of this square is equal to 19 feet. But they want the perimeter. So perimeter is going to be 4 of those, because remember, perimeter is all of the outsides added together. So you could just do 4 times 19. which gives us 76. So the perimeter of this square is 76 feet. And then once again, remember, perimeter is not square units, it's just regular units. So we'll just put feet. All right, and then this last problem in this section, this looks like it is about a trapezoid. So it says find the length of the second base of a trapezoid that has one base measuring 12 feet and a height of 4 feet and an area of 50 square feet. Okay, so let's go ahead and write the formula, and then we're going to fill in all the information that we have. So trapezoids are 1/2 of the height times the sum of the bases. So let's see, we're asking for the second base, and they're giving us one of the other bases, right? So base 1 is 12 feet. So that's going to go right here for base 1. And then they also give us the height. The height is 4. So that's going to go in for the height right here. And then we have the area as well. So the area is 58. That's going to go right here for area. So let's go ahead and fill in all of this information. So we have 58 equals 1/2 of the height, which was 4, times base 1, which is 12, plus we do not have base 2. So I'm just going to leave that as B2. So here's our setup here, and we're trying to solve for B2. So solving this one is a little different than our other trapezoid problem. So let's go ahead and try to simplify some of this. You can start by doing 1/2 of 4, just to clean that up a little bit. 1/2 of 4 is 2. So we would have 2 times 12 plus B2 equals 58. Okay, now you have a couple of options here. So some people are going to want to distribute this 2, and you can do that if you'd like. I mean, it will still work. You'll be able to solve the equation. But because we're trying to isolate this B2 here, we're trying to get that by itself, I prefer to just divide this 2 off on both sides. Because remember, this 2 is being multiplied by this quantity. So if you want to undo that multiplication, you can just divide it off on both sides. So if you divide both sides by 2, these 2's would cancel, and you're just left with 12 plus B2. And that's going to equal 58 divided by 2, which is 29. And then now to solve for the second base, you could just subtract 12 from both sides. So you would get 17. So the second base of this trapezoid would be 17 feet. Okay, now we're going to take a look at an application example. So this is a real life application. Let's go ahead and read through it and try to figure out what they're asking for here. So it says, Mr. Payton would like to paint his deck. The dimensions of the deck are shown below. So it looks like the deck is shaped like a trapezoid, right? And 1 can of paint covers 72 square feet. How many cans will he need for 2 coats of paint? Okay, so basically we need to know the area of this surface because we got to figure out how many cans of paint we're going to need, right? So if I knew how much area this took up, we could figure out exactly how many cans we would need. So I would start by finding the area of this trapezoid. So remember, trapezoids are 1/2 of the height times the sum of the bases. And let's take a look at this picture here. So the bases are these parallel sides. So 14 could be base 1, and 24 could be base 2, and then the height is always perpendicular to those. So the height would be this 16.5, which means we're not using these sides over here when we're doing area. So let's go ahead and calculate that. That would be 1/2 of 16.5 times 14 plus 24. Okay, so you can go ahead and put that in your calculator, figure out what that would be. And I'm going to write down what you should be getting for that. You should be getting 313.5 square feet. Now, that's not the answer, right? Because that's not what they're asking for. It says, how many cans of paint will he need for 2 coats of paint? So what I would do is figure out how many cans of paint he would need just for 1 coat. So if this is the area of the deck and 1 can of paint covers 72 square feet, we need to see how many 72s fit into this number right here, right? So you're just going to divide this by 72, and that will tell you how many cans we need for 1 coat. So that's about 4.4, and but that's for one coat of paint, right? So 4.4 cans would get us one coat of paint. We want 2 coats of paint. So you can just times that by 2. So if I times that by 2, it is 8.8. Now, because this is a word problem, we can't buy 0.8 of a can. You can't buy a partial can of paint. So we're going to round this whole thing up to the nearest whole number. So we would need 9 cans total to cover that whole surface to do 2 coats of paint. Okay, we have one more thing to talk about. Go ahead and turn the page. We're going to talk about composite area now. Okay, so on this last page, we are going to talk about how to find the area of composite figures. So what is a composite figure? It's a figure that's made up of multiple shapes put together. And there's a lot of different ways to find the area of something like this. So if you just look at this first example here, we have this like L shape, right? And we want to find the area, the total area that all of this takes up. So the best way to go about this is to just split the shape up into multiple shapes, and then you can find the area of each piece. And there's not really a right or wrong way to do this. Some people might choose to split the shape up like this so that you have this tiny rectangle up top and then the bigger one on the bottom. So that's totally fine. Or you could split the rectangle up like this. So you have this rectangle here and this one here. Some people might even try to do 3 rectangles, which is totally unnecessary. I would just try to split it into as few shapes as possible. But yeah, that's how you can go about finding the area of something like this. So I think I'm going to split it like this. Okay, so let's focus on that top rectangle first. So remember, rectangles are just length times width. So the length of this rectangle is 7. Now the width, we have to figure that out because it's not going to be 18, right? 18 is this whole piece right here. However, if you look at the whole picture, we know that from here to here is 11. That means from here to here would also be 11. So if I want to figure out the length of that little piece at the top, we would just do 18 minus 11, which gives us 7. So that means that this rectangle here is actually a square, and I know it doesn't look like it, but it must just not be drawn to scale because the math works out. This would have to be 7. So the area of this purple rectangle here or square would have to be 7 times 7, which is 49. And then now we're going to find the area of the rectangle on the bottom. So this green rectangle here, that would just be 11 times 16. That's the length and the width of that rectangle. So that would give us 176. So then the total area of this whole shape would be 49 plus 176, which is 225 square meters. So that's how you find the area of these strange looking shapes. You just have to split them up into multiple shapes. Okay, so let's take a look at the next one. We're going to try to split this up somehow. So again, there's not really a right or wrong way to do this. Some people would try to make it into a triangle like this. This is probably how I'm going to do it. We would have this big rectangle here, and then we have this triangle over here. Or you could also draw a line right here if you'd like, and then you'd have a rectangle up top and then a trapezoid on the bottom. However you want to do it is fine. But I'm going to do it like this. So we have this bigger rectangle over here. That area would just be 4 times 5. So that rectangle would equal 20 square inches. And then let's work on the little triangle here. So I'm going to need this purple length, and I'm also going to need the length of this bottom side here. So one thing we know is that the length from here, from here to here is 3. And we know that this whole vertical side over here was 5. So that means this little purple piece has to be 2 because the length of this whole side would also have to equal 5. So 3 plus 2 is 5. And then down here, the whole entire length is 7. And we know that that top of that rectangle up here, it's 4. So this is 4 down here. So that means that this blue piece would have to be 3 because it's got to make 7, right? 4 plus 3 is 7. So this triangle over here, this is a 2. It's got a height of 2. It's got a base of 3. This would be a right angle here. So the area of this triangle would be 1/2 base times height. So 1/2 of 3 times 2, which is half of 6, which is 3. So the area of the triangle is 3. That means the total area is 20 plus 3. So we have 23 inches squared. Okay, let's take a look at the next shape. Now the next shape, it looks like it's already split for us, right? So if we look at the shape as a whole, we're trying to find this whole area here. You can think of this as a rectangle that is on top of a trapezoid. So we'll find the rectangle first because that's the easier part. That's just going to be 12 times 23. So 276. And then trapezoids, those are a little bit harder. So remember the formula is this: 1/2 of the height times the sum of the bases. All right, so let's work on finding all the information that we need. So the bases are the parallel sides, and we do have those. So we have this one's 15, so that's one of our bases. The other one is this side right here, and we know the length of that because it has to be the same as this side up here. So that's 23. So all we're missing is the height of this trapezoid. So remember, the height is going to be this perpendicular distance here to the bases. So this little blue line right here. You can also think of it as being out here, right? So this is the height. Now we know that this whole entire length is 18. And then we also know that this side over here is 12, which means this piece here is also 12. So that means the height has to be the difference between 18 and 12. So the height here would have to be 6. So now we have everything we need to find the area of that trapezoid. So it would be 1/2 of 6 times the sum of the bases, which are 15 and 23. And we can just calculate all of that. This would be, let's see, 3 times the sum of the bases. If you calculate that out, it should be 114. And then now we can find the area of the whole shape. It would just be 276 plus 114. So that gives us 390 square centimeters. Okay, so that's how we deal with composite shapes. You just add them together. Find the area of each individual shape, and then you just add them together. Now we're going to talk about how to find the area of a shaded region. So what if we only wanted like a portion of the shape? So instead of adding two areas, this is going to involve subtraction. So in this first example, we are only finding the area of the shaded region for all of these. So I only want this gray space right here. So the best way to do this is find the area of the outer shape and then find the area of the inside shape, and then you can just subtract those, right? We're going to take the big one minus the small one. Think of this as like a piece of paper that has a hole cut out of it, right? So the area of the outer one, the purple one, that would just be 5 times 5, because this is a square, so that's 25. And then the area of the rectangle on the inside, that's just 1 times 4, which is 4. So the shaded portion would just be 25 minus 4. So 21 square centimeters. Okay, the next one, it looks like we have a rectangle. If we're looking at the outside shape here, that's a rectangle. And then the hole that's being cut out of it, this white area, this is a triangle. So we're going to find the area of the rectangle, the area of the triangle, and then we're going to subtract. So the green rectangle would just be 25 times 14. So that is 350. So that the inside of this rectangle would be 350. And then the little triangle would be 1/2 base times height. So the base would be this side over here, which we know is 25 because it's the same as this side over here. And then the height is this 11, they're perpendicular. So it would be 1/2 of 11 times 25. And that equals 137.5. So now we're going to take the rectangle, which was 350, and we're going to subtract the triangle, which was 137.5, and then whatever is left over would be the area of the shaded portion. So that should be 212.5 square centimeters. Okay, and finally this last picture here. So if we look at the outer shape, we have a rectangle again. And then this time it looks like we're taking off two little triangles. So we're taking off this little corner here and this little corner here. And if you look at the markings, those two triangles are congruent, right? We have like the two sides are equal. So let's find the area of the rectangle first. That would just be 32 times 16, which is 512. And then we're going to find the area of these little triangles. So it's a 4 by 6 right triangle. So we have 1/2 of 4 times 6, and that would be 12. So if you multiply that out, that's 12. But each one of these would be 12. You have two of them, right? So we're going to do 512 minus 24 because we have two of those little triangles, right? 24. And then that would give us the area of the shaded portion. So it should be 488 square feet. All right, that is it for the notes today. You can go ahead and start on the homework.